So moving right along, our next thing is we are going to be solving. So when you're solving, the first thing that you always need to do is you need to get your radical or your rational root, which is your rational exponent. That's where you have a fraction as an exponent. You need to get it by itself on one side, and then we go through and solve. So for number 29 here, I have my radical here. I have an extra plus 4. And so how do I get rid of a plus 4? I don't add 4. I don't know why I would write that. I'm going to subtract 4. So, and 11 minus 4 is 7. Okay, and so I have radical 5x minus 1 is equal to 7. The opposite of taking the square root is actually squaring it. And so we do that to each side. So we end up with 5x minus 1 is simply equal to 49. I add 1. I add 1. 5x is equal to 50. Divide by 5, and x is equal to 10. Now, right here it says check for extraneous solutions. So you need to make sure that the answers that you get do work out in your problem. So you just simply plug in whatever you get for x into the original problem. So this is 5 times 10 minus 1 plus 4 is equal to 11. That's 50 minus 1. That's going to be radical 49 plus 4 is equal to 11. 7 plus 4 is equal to 11. 11 is equal to 11. And that checks out. So my answer is indeed 10. I move on to 30. Method doesn't change. I need to get my radical. So I look at what's outside my radical. I have a 1 and a 2. Okay. The 2 is being multiplied. Okay. I don't want to get rid of multiplication first. So if this 1 is on the outside, okay, like that, then I know that I need to subtract it. So I'm going to subtract 1 first. So this is negative 2 times m plus 12 is equal to 4. Then I want to get rid of my multiplication. So I divide by negative 2. So I have radical m plus 12 is equal to negative 2. Same thing with the previous problem. This was a square root. To get rid of a square root, I square it. So I square each side. So it gets rid of my radical symbol, so I just have regular m plus 12, and negative 2 times negative 2 is positive 4. I subtract 12 from each side. M is equal to negative 8. Okay, so that's looks to be my answer. I plug that into my original problem. So I plug that in for m. 2, that's negative 8 plus 12 is equal to 5. So I simplify negative 2. Negative 8 plus 12 is 4 is equal to 5. 1 minus 2 times 2 is equal to 5. 1 minus 4 is equal to 5. And I end up with negative 3 is equal to 5. That is not true. So this right here, that cannot be the answer. So this is no solutions. And that's why it's important to check. Otherwise, you're going to lose points. Moving on to 31. 31 is pretty much taking care of us. So this is like a little bit less of a step. So what I need to do is I need to get rid of this 1/3. So you always multiply by the reciprocal. So the reciprocal of 1/3 is 3, or not multiply. You take it to the power of the reciprocal. Excuse me. So I'm going to take each side to the third power. If you do it to one side, you have to do it to the other for the equation to remain balanced. So I have 9a plus 45 is equal to 3 to the third power is not 9. Remember, it is 27. I subtract 45, subtract 45. I have 9a is equal to negative 18. Divide by 9, divide by 9. I end up with a is equal to negative 2. I plug it into the original problem. So 9 times negative 2 plus 45 to the 1/3 power should be equal to 3. Put all that in my calculator, I end up with 27 to the 1/3 power is equal to 3. 3 is equal to 3. So a equals negative 2 is indeed my answer. Okay. This one here, it looks pretty bad, but I noticed that it's to the 1/2 power. How do I get rid of taking something to the 1/2 power? I square each side. And remember, you multiply this. 1/2 times 2 is 1. 1/2 times 2 is 1. So now I'm left with 3n minus 27 is equal to plain old 43 minus 2n. I always like to get my variables on the same side first, so I add 2n to each side. So this is 5n minus 27 is equal to 43. I add 27 to each side. 5n is equal to 43 plus 27 is 70. Divide by 5, divide by 5, n is equal to 14. I plug it in to each side, so this is going to be 3 times 14 minus 27 to the 1/2 power is equal to 43 minus 2 times 14 to the 1/2 power. When I put each of these into my calculator, I end up with 15 to the 1/2 power is equal to, and I end up with the same thing here, 15 to the 1/2 power. And so you can check to see if the decimals are the same, but you know that these are the same problem. So if you didn't have a calculator, you could just show that right there. So n is indeed equal to 14. Okay, on to a couple more. So number 33, don't get overwhelmed by the fact that there's a k here. We're going to still do the same thing. So how do we get rid of a square root? You square each side. Okay, so this is 18 plus 7k is equal to k squared. Now, we kind of run into a little bit of a problem here, and actually goes back to the last unit with quadratics, is we have this k squared here, which means we have a quadratic. In order to solve a quadratic, no matter what method, pretty much, you have to set it equal to 0. Now, I like my k squared to be positive, so I'm actually going to subtract 7k from each side. So this is 18 is equal to k squared minus 7k. And then I'm going to also subtract 18 from each side. So I have 0 is equal to k squared minus 7k minus 18. Now, you have one of two options pretty much here, because you're not going to have Desmos on the test, is you can either factor, or you can use the quadratic formula. Okay, if we were to factor, we're looking for, we know the k squared goes here, the negative 18 goes here. We're looking for two numbers. They have to multiply to be negative 18, and they have to add to be negative 7. 18 doesn't have many factors. You have 6 and 3, but the difference is not 7. We also have negative 9 and positive 2. Okay, so I do the same thing. I go my common factor here, my common factor here, and my greatest common factor here. Okay, so when I factor this, this ends up being k plus 2 times k minus 9 is equal to 0. So that's the factoring method. It's fine. We can also use the quadratic formula. And so just finish this up, sorry. So either k plus 2 is equal to 0, so k is equal to negative 2, or k minus 9 is equal to 0, k is equal to 9. Okay, if I use the quadratic formula, x is equal to negative b plus or minus the square root. Remember to put this in parentheses, b squared minus 4 times a is 1, because whatever's in front of the k, c all over 2 times a. And you get the same thing. You do negative 7 plus whatever's underneath the radical, negative 7 minus whatever's underneath the radical, and you would get your negative 2 and 9. So, unfortunately, the pain with this one is you do have to do a check, and you have to check both answers. So I'm going to check the first one, I'm going to check my negative 2. So if negative 2 works, then 18 plus 7 times negative 2 should be equal to negative 2. I already know that this is not going to work because you can't take the square root of a number and get a negative, but we'll go through this anyway. So this is the square root of 18 minus 14 is equal to negative 2. The square root of 4 is equal to negative 2. Is 2 equal to negative 2? No, it is not. So negative 2 is not a solution. Make sure you do check your second answer because there may be no solutions at all. So I go through 18 plus 7 times 9 should be equal to 9. So I have 18 plus 63 is equal to 9. The square root of 81 is equal to 9. 9 is equal to 9, and it does check out. So therefore, your only answer is K is equal to 9. 34, the last one of the solving. For this, the first thing that we start with is always the fact that you have to get everything outside of a radical by itself. So right now I have this negative 4 that's outside the radical. So I do have to get my radical by itself to square each side to make it work. So I end up with radical 6x plus 19 is equal to, I can't combine these, so this is just x plus 4. It's fine if it's a binomial. We'll talk about that in a moment. So I do go back through the same thing, and I square each side. So this ends up being 6x plus 19 is equal to x plus 4 squared. Now you have to be really careful with x plus 4 squared, because remember that x plus 4 squared is x plus 4 times x plus 4. Okay, so I'm just going to do a little box to do that multiplication. So it's going to be x and 4, x and 4. So this is x squared, 4x, 4x, and 16. So I have 6x plus 19 is equal to x squared plus 4x plus 4x plus 16. 6x plus 19 is equal to x squared plus 8x plus 16. And we're back to kind of where we were with the previous problem. I do have a quadratic. I know I have a quadratic because I have an x squared term, so I need to set it equal to 0. So I subtract 6x, I subtract 6x. I can subtract 6x's from 8x's. I have 19 is equal to x squared plus 2x plus 16. I subtract 19. I have 0 is equal to x squared plus 2x plus, or excuse me, I said plus, it should be minus 3. I go through, I'm just going to do the factoring. If you were to do the quadratic formula, A would be equal to 1, B would be equal to 2, and C would be equal to negative 3. I do believe it's a little bit more work than factoring for this case. This would be x squared, this is negative 3. We're looking for two numbers, they multiply to be negative 3 and add to be 2. 3 does not have many factors, so this is going to be 3x and negative 1x. Greatest common factor here, greatest common factor here, here, and here. And so my factored form is x plus 3 times x minus 1. So x plus 3 times x minus 1 is equal to 0. So either x plus 3 is equal to 0, x is equal to negative 3, or x minus 1 is equal to 0, x is equal to 1. I have to go back through. I do have to check both the answers. So the first one I'm going to check is negative 3. So 6 times negative 3, that's a negative 3, plus 19 minus 4 should be equal to negative 3. So this is going to be the square root of negative 18 plus 19 minus 4 is equal to negative 3. The square root of 1 minus 4 is equal to negative 3. 1 minus 4 is equal to negative 3, and negative 3 is equal to negative 3. So that checks out. I do the same thing with 1. So I plug it back in. 6 times 1 plus 19 minus 4 is equal to 1. The square root of 6 plus 19 minus 4 is equal to 1. The square root of 25 minus 4 is equal to 1. 5 minus 4 is equal to 1. 1 is equal to 1. So actually both of these are your solutions. X can be -3 or 1. And that is solving for you.